we continue with this session, afternoon session. I don't know which problem take for this session. Maybe let me check here. Reorder roots. Yeah, we can try with this. Let me clean this. Okay, yeah, we can do this. I remember I tried to resolve a few days ago, and obviously I don't resolve it, but I learned how to do. Well, in this case is reorder root to make all paths lead to city 0. It's the problem 1466. Yeah, and there are in cities number from 0 to endless 1 and endless 1 routes, such that there is the only way to travel between two different cities. The network for a Mach 3. Last year, the Minister of Transport decided to order the routes in one direction because they are too narrow. Routes are represented by connection, where connection in the index I is X, and well, in this case is A and B, but it's basically the points in the map X and Y. Represent a route from city A to B to city B. This year there will be a big event in the capital, city 0, and many people want to travel to this city. Your task consists of reorienting some routes such that each city can visit the city 0, return the minimum number of the edge change. It's guaranteed that each city can be reached city 0 after reorder. Okay, it is an example. Let me check the constraints. The constraints is that the minimum value is 2, and the max value is like this. Connection length it's equal n less 1. Okay, the value of the connection is 2 always. A or X in this case is equal greater 0, and B is the same, and minor equal less 1, and A it's different to B. Okay, well, basically with this problem the idea is that let me copy this. We can increase. Yeah, okay, basically the idea is that reoriented the no, it's not reoriented, it's only count how many, because it's only return. Yeah, it's only count how many paths we should change for get that the all cities reach 0. Yeah, in this case one moment. One moment, please. Okay, now yeah, this is the idea. For example, here the black arrows means the original direction. The 0 will go to the 1, and 1 to the 3, and the 3 is still in this case. Basically the 2 go to the 3, the 4 go to the 0, and go to the 5. But the idea is that every node or every city should have the possibility to reach 0, you know. And for two reasons. For example, this change the direction for this, and this for this, and this for this, because in this way, do you imagine that, for example, the 2 reach the 0, yeah, with these directions, yeah, for example, this, okay, the 3 reach the could reach the 0, yeah, the 1, yeah, the 4, okay, and the 5, yeah, okay, and the idea is how many paths we should change, yeah, it's only two possibilities, the way it's a right way or a wrong way, only that, yeah. Okay, for this I remember, or I learned that, let me try to clean this for one moment, please. Okay, now I remember that for this exercise, we can mapping all the values yeah, mapping this graph, direct graph, and mapping as a indirect graph. You know, for example, the 0 go to the 1 and go to the 4, the 1 go to the 0 and go to the 3 in both directions. Sorry, here is the 3. Sorry, 0, 1 go to the 0 and go to the 3, the 3 go to the 1 and go to the 2, 2 only with 3, and 4 go to the 0 and go to the 5, and 5 go to the 4. Yeah, the idea is mapping in both directions, yeah, and save okay, we have this, yeah, I remember. You should have this map, yeah, in these directions, that basically it's only for move between directions, or in the graph, it's only for that, yeah. Next to, we should emulate that we want to go to the final of this graph, start here and end here, yeah. And basically every time that I found these directions means that is wrong, yeah, because the idea is that I will start here in the 0, yeah, and all the answer are wrong because I am in the wrong way, or in the wrong direction, yeah. We start here and we finish here. I am in the wrong direction, but makes sense because basically if I found this in the mapping, basically is wrong, yeah. For example, the 0 to 1 exists here, 0 to 1, yeah, exists. 1 to 3 exists, yeah. 3 to 2 exists, but in this case, for example, the question is wrong. It's 0 to 1, 1 to 2, no, 0 to 1, 1 to 3. Now the 3 go to the 2, but we avoid the question because the direction in this case is it's not the real, it's not the wrong direction. Yeah, for this, in this case, for two reasons, don't count another here. But let me remember, I remember that we will start in the 0 and go to the, in this case 2, and go to the 5. Okay, I have mapping this map, and basically is have an hash set as a string for mapping. Okay, 0 to 1. Okay, the 0 to 1 exists here. Yeah, exists. Okay, it's 1. Now move to the next. The next is but I don't remember. 0 to 1. Okay, it's in the map. Yeah, I remember that it's necessary have the map in both directions. One, 2, 3. Oh, I forget to check if I have the session in Twitch. Yeah, it's, yeah. Okay, it's 0 to n, but we can avoid this and only map the original path. 0 to 1, 1 to 3, 2 the 3, and 4 to the 0, and 5. And we start with 0, a 4 that start in 0, and we should, no, but how note that? No, this is wrong. It's necessary mapping in both ways, sorry. Okay, we have here the map, and basically here, and is well, we know that is 0, 1, 2, 3, 4, because we know that n, and n in this case is 6 because it's endless 1. Okay. 5. Okay, and in this case, for example, 0 to 1, this is a list, and 1 to 0. Okay, 1 to 0, it's done. 1 to 3. Okay, it's 3 to 1. Now the 3 to 1 is okay. 3 to 2. Okay, now it's 0. No, yeah, 0 to 4, and 4 to 0, and 4 to 5, and 5 to 4. Yeah, and now it's basically start in T0, but let me check in which moment the 0 appear in this case is the first element, and here, yeah, it's the first element. We start here and we end here. Okay, even let me copy these values. Oh, okay, and we start with the first. The first is 0 to 1. This is 0. this is 0, 1, 2, 3, 4. We start here and we say 0 to 1 is wrong, because basically x is equal 0, y is equal 1, yeah, and we know that it's in the wrong way because the 1 should be go to the 0. Okay, 0 to 1. And here is it's a scene that is a hash set where we should save the direction that I visited before. Yeah. In this case, x is 0, y is 1, and we should move. Okay, the 0 is this. Okay. I will get the 1. No. Okay. I remember, I know that 0 to 1, 1 to 3, 0, we start in the 0, and is 0, okay, to 1, 0 to 1 exists. Okay, got it. Here, yeah. Basically all this direction, no, but I should save the wrong directions. Yeah, in this case, for example, what happens if I save this direction? 0 to 1, 1 to 3, 2 to 3, 4 to 0, and 4 to 5. What happens if I save this and I mark it as a scene? Yeah, no, as a scene, no, as a wrong. Yeah, and basically we start in the 0. We know that it's our point of the star, or start point, sorry. And basically, okay, 0, what is the values? Is 1 and 4. Okay, 0, 1 appear here. Yeah, it's wrong. We know it's wrong because basically all the cities should be, it's a decreasing order, you know. If you have 5 elements, it should be reduced 4, 3, 2, 1, 0. That is the goal. In this case, we are in the wrong way with the purpose to discover how many paths match with this. Basically, if match is wrong. In this case, for example, okay, in another we should save 0, 1 as a visit. Yeah, and 0, 1 no, only 1. 0 and 1. Yeah, in this case, for example, the 1, 0, the values are this. Okay, the first element is 1. 0, 1 appear here. Yeah, okay, is 1. Now go to the 1, and it's 1. Return the 0. 0 has been visited before. Yeah, and the other is the 3. Yeah, 1 to the 3 appear here. Yeah, means that is another wrong way. We should add the value here, and here is the 3 now, and the 3 is 1 and 2. 1 and 2. 1 has been visited before, yeah. 2 has been visited before, no. Okay, we should ask 3 to appear here, no. Okay, only add the number 2, and now to the number 2 return only the 3. The 3 has been visited before, yeah, is here. Okay, this is complete, this is complete, this is complete, and this is complete, yeah. Now the next step is we start with the 1, go to the 2, and we should validate 2 is here, yeah. 3 is here, yeah. 4 is here, no. Okay, we start with the 4. Let me put here the 4. It's 0 and 5, 0 and 5. 4 to 0 is here. No, sorry. The 0 it's a void because has been visited before, yeah. The next is the 5. 4 to 5 is here, yeah. In this case, increasing 1, and go to the 5, and obviously here appear the 4 and appear the 5. 5 return the 4. 4 has been visited before, yeah, and in this case the answer is 4. Yeah, this is the idea behind the solution or this problem. Go to in the wrong direction for discover how many ways match in the path, and basically every way, yeah, or every sub path that match in this direction is wrong automatically, yeah. Now for this I don't like this function of the leetcode. I really don't like. I can I would like to disable this option because no, it's not comfort for me or comfort to me. Okay, now one moment please, I am checking. Okay, now okay, we are here. Now the first that is the map. In this case, basically it's an DFS. For the reason, I will create the hash map here. Hash map. Here is a string, and no, it's not a string. It's an integer. And here is similar integer, yeah, both are integer because basically every node it's a number, only a number, because is 0, the sequence is between 0 and the final is endless 1. This case is a map, it's equal new hash map, yeah, and no, here it's only for create the variable, and here don't have any difference, but I always I'm trying to do it this way. Okay, now the next that is we have this, and now integer counter, yeah, for the default is 0, but only with the purpose to show the value. I set the initial value here, and what else? The hash set, yeah, hash set as a string set, and is similar with the sim, but with the integer. And here is yeah, one. This is for paths, and this is scene. Yeah, and initialize here. But it's equal hash set and it's similar with the scene. Okay, in this okay, now the next is for each integer I it's equal 0, meanwhile I it's minor to n I plus plus, and basically it's map.put I new array list for initialize all the map, and next to is that for each the connections for sorry direction well, count connections integer x it's equal count in the index 0 and y it's in the index 1. Yeah, and here basically is scene dot it's count paths dot add, and here I can add x any value and y only for divide the values, one for example 1 in x and 1 in y, but it's only because this character is only when you have for example 11 and here 3, for don't combine and create a number that doesn't exist. In this case it's only for that. And in the map.put x here is get dot add y. Yeah, we are creating the unidirectional graph. Yeah, okay, now it's done here. Now the next step is another for integer I it's equal 0, while I it's minor to n I plus plus, and here is if scene contains, in this case is I, here is the fs, and here we can add scene dot add in the index I, and here we should add the index and connection only this, and this don't return anything. Here is return counter that it's a global variable that I declare here. Oh my gosh, counter is basically yeah, this is the answer. Now we should create the DFS integer node. Yeah, and here I should apply a for integer n on neighbors. Always neighbor. Always I forget how write neighbors. And here is map.get and node. Always Always this map should return any list, even if the list is empty, because for this reason I create this for. And next to is basically if scene that contains this is neighbor, no neighbors, it's a neighbor, yeah. If it's not contained, please scene dot add neighbor in DFS neighbor. But okay, with this we only add with this we only go to this direction. And now here is if scene is not contained. Okay, here receive this number as 0. Okay, is contained? No, because it's empty. Okay, please add to the scene and mark as a scene this node. In this case, scene have the value of 0. DFS, this DFS receive the 0, and basically is okay. Please, I need the neighbors of the number 0, that is in this case is 1 and 4. Okay, 1, the first is 1 is here. No, please add, and this value is 1. Okay, go to the 1 in this case, and is okay. I need here is a map.get of the node 1. The 1 have 0 and 3. The 0 is contained? Yeah. The 3 is contained? No. Okay, mark the 3 as a scene and DFS with the number 3. Okay, now this is 3. Okay, the nodes that are connected with the 3 is 1 and 2. 1 is marked as a scene. Yeah, the 2 is marked as a scene before. No. Okay, go to the 2, and now the 2 is basically only with the 3. The 3 marked is as a true, is complete, is complete, is complete. Okay, now this this code works only for go to the 0 to the final element, in this case 0 to 6, yeah, basically. Now, actually sorry, now I will detect when yeah, I need detect where the direction, yeah, here is if neighbor, that is in this case is x, and no, it's node, a neighbor exists in paths. If exists, basically is add or increase the counter. And here is this section. Yeah, it's create string temp, no, hash. It's equal, in this case, node plus neighbor, yeah, and basically is this exists in the path, but contains this is wrong. Counter plus counter counter plus plus and mark as a visit, and I'm not sure that is, yeah. Oh, hash set. In the new, what happened with the new array list? What? What another map.get, mat.get, and add y. Yeah, it's in plural, but yeah, it works. I would like to test this code with another test, but I think well, I think that we don't have more tests. Nice. Now let me copy this, because always I publish my solution here in my Twitter. And this problem is the problem this, and obviously the emojis, city, no, yeah, here, and my answer is this solution using DFS graph. Yeah, DFS Java. Now let me check if we have another thing. No, this is my solution. I will put here, and obviously this is my second the first time I try it in another way, but doesn't works, but it didn't works. Okay. Okay, now it's raining here. I think that this emission will be a short emission. Thanks for watching.